guys, welcome to Learn Extra Live Maths Literacy. I'm Katleho and this is Topo. How are you, Topo?
Hi, I'm fine, thank you. And you?
Good, thank you. Topo is one of our top 10 presenters, guys. How does it feel?
It's nerve-wracking at the same time. I'm enjoying, hey.
That's
it's a nice
great, eh?
to
And
be
how does
here.
it feel to be here today?
It's overwhelming. I met everyone and it was nice, you know.
It was nice, eh?
Yes,
We also
yes.
enjoyed it here. And guys, you guys know, those of you who have been in the studio, it's really so much fun. And guys, since we're doing maths literacy today, it's Thursday, it's a stunning day. You guys need to focus, guys. All we need today is your 100% attention because it's going to be such a fantastic show. We are on Facebook, as you guys know. This is where you can ask anything that you need to ask. Our Twitter handle is @LearnExtra. And do you remember our Facebook?
Yes, you can go to www.facebook.com/LearnExtra and you can post any question that you have.
That's it, Topo. Guys, you heard him. We are here to help you guys. There's two of us, so it's double, I don't want to say double trouble. What's another word that we can use?
Double joy.
Double joy, yes. It's double joy. And today, we're with Haley. Haley, how are you today?
Hi, Kat. Hi,
Hi.
Topo. Welcome.
What
Good
are
to
we
have
doing
you here.
today?
Today we're going to be doing measurement.
Okay.
And we're going to be looking at, last week we did measurement, we did area and perimeter. Today we're going to be doing volume and surface area. So it's going to be fun. So
Thank you, guys. So it's going to be a lot of fun. And today our show is sponsored by Macmillan. Thank you very much, Macmillan, for sponsoring such an awesome show. Take it away.
Thanks. Okay, so like I said, we're doing measurements. So we're going to look at measurements, carry on from last week. So let's just look at what we're going to be doing. We're going to focus on calculating the surface area of rectangular prisms, triangular prisms, and cylinders. We're then going to focus on calculating the volume of the same prisms, the rectangular, the triangular, and the cylinder. And finally, something that I know a lot of you guys actually struggle with. And I'm going to explain when I do the calculations how you avoid this, but converting from one squared or cubed unit of measurement to another. So when we end up with an answer of like centimeters squared and they want to know the millimeters squared, what do we do? Because I know that most of you guys actually struggle with that. So let's see what our key concepts are. So our key concepts for today. So in order to calculate the surface area of a three-dimensional shape, what we basically need to do is flatten the shape and calculate the area of all the sides. So kind of like if you take your three-dimensional shape and you unfold it so that it's flat, and then you've got a two-dimensional shape and you just work out the area. So there's nothing really hard about it. It's just a little bit of understanding. We did area last week, so I'm hoping that you guys just follow on. A rectangular prism is a three-dimensional shape with 6 rectangular faces. The opposite faces of a rectangular prism are always equal and parallel. So it's important to know that. If I look at something that was a rectangular prism, I've got those two sides are equal, those two sides are equal, and then the top and the bottom are equal. Then they will always give you the formula. So don't panic. And please, I had an incident with my matrics today where they decided to make up their own formula. Use the formula that you are given. So for surface area, it's basically 2 times the length times breadth plus 2 times the length times height plus 2 times the breadth times height. Sometimes they take this 2 out and they say, well, it's 2 times length times breadth plus length times height plus breadth times height. What I want you to do, I'm just going to quickly draw a rectangular prism. What I really want you to do when you see this in your test or in your exercise, take a pen and label each one of the sides. So make that the length, make that the breadth, and make that the height. And it really doesn't matter which is which. But then it makes it easier to substitute the values into the equation. And you don't end up thinking, well, have I done this one already? Or have I left it out? Or what is the situation? So it's quite easy. So we're looking at 2 of those, because there's one there and one at the back, 2 of those, one at the top, back, and 2 of the sides. So follow the formula. Let's move on to the triangular prism. Now I'm going to try and draw one of these. So triangular prism is also a 3-dimensional shape, 2 equal triangles and 3 rectangular faces. So if I had to draw it, I've got a triangle, And that would be like kind of 3 dimensions. Right, so what do I have here? I have this triangle here, and at the back I've got the same triangle. Those are my 2 equal triangles. And then each side, so if I actually had to unfold it, I've got a triangle that's attached to the base. And on the opposite side of that, a triangle. And then I've got a rectangle and a rectangle. So that is why if we unfold it, we can see we've got 3 rectangular faces. There's 1, 2, 3, and we've got 2 equal triangles. So the formula is the 2 times half base times height. That is the formula. This formula in the brackets is for the triangle. So that's the triangle, and we've got 2 of those. So that's easy enough to do. And then we've got side 1 times height. So if I had to take my triangle here and make this side 1, let's make this, let's change that a sec. Let's undo that for a sec, make it easier. This side 1, that side 2, and that side 3. My rectangle is the side 1. It's the same side as that side of the triangle times the height, and this becomes the height of the shape. Side 2 and side 3. So we end up with 3 rectangles. And this really does depend on what your triangle measurements are. So pick it up from there. And again, probably easier to label them. So label side 1, side 2, and side 3. And then you know that that's your height. So it makes it easier to substitute into the equation. Then let's move on to our cylinder. And again, this is a shape with 2 equal circles and a rectangular face. So let's change color for a bit. We've got a circle. There's my cylinder. Whoops. If I had to actually unfold it, I have got 2 circles, a rectangle. Well, that's 1 circle. Let's put the other one in. And that circle. Now, what's important to note about the cylinder is that this shape over here, this line here, is the same line that goes around my circle. So it is actually, this line there is actually the circumference, and remember we did this last week, the circumference, I don't know if I'm spelling that correct, the circumference of the circle. So our formula is a rather strange formula, but in actual fact it is made up of the fact that it's 2 circles. So pi r squared is my circle. I've got 2 of them. And then this part of the formula, this 2 pi r h, is my length times breadth. But my length of this is 2 pi r. That's my length of my rectangle. And this is my height of my cylinder. So that's where the 2 pi r h comes from. And they might give you the formula looks slightly different because you can kind of take out common things. Just follow the formula that they give you, and then you'll be fine. So again, I would label. We always need the radius, and you need to label your height. And with that, you can carry on the question. Let's move on to our volume. So volume is used to measure the amount of space inside a 3-dimensional object or container. Now it's how much is inside. And we use this often when we look at capacity. Like if I look at how much water goes into a bottle, I need to work out the volume of the bottle. And then I convert my centimeters cubed to milliliters. So we use it with capacity. So a rectangular prism is just length times breadth times height. Fairly simple. Again, take your prism and label length, breadth, height. And again, it doesn't matter which way you label them, as long as you follow the same rules. Okay? A triangular prism, slightly harder. Now, what I like to say to my kids when I'm teaching, when we work out volume, it is kind of like the area of the common side times by the height. What do I mean by that? If I look at a triangular prism, and if I had to cut this anywhere along the shape so that I continue to get this triangle, my triangle is common throughout the shape. So that becomes my area of my common side, and there I would see that half base times height, and then finally I multiply that by the height of the shape. So I could give you any strange kind of shape. As long as we know the area of that shape, we can work out the volume of it. Let's try to do one of those quickly. So let me give you a funny shape of something that looks like that and tell you that that's 9 meters squared. So the area of that is 9 meters squared. Now, if this was a pond, and I had to tell you that the depth of the pond, so the height was 0.5 meter, I could work out the volume of this pond, because all I need to do is my volume is actually my area times my height. And my area, I know, is 9 meters squared. So although it's this funny shape, I know the area of that, and I can times it by my height, which is 0.5, and then I don't think we need a calculator for that. So 4.5 meters cubed is my volume now of my pond. So we use that theory when it comes to our triangle, our triangular prism. We have the area of the triangle times the height. And guess what? We are going to do the same thing for the cylinder, because the cylinder, the area of the circle times the height of the cylinder. My common shape is my circle. That's the one where all the way through, if I cut it along, it is going to still be a circle. So my area of my circle is pi r squared and my height. So on my diagram, that would be my height, and there's my radius. Okay, so I hope that you guys are following. There's a lot of information there, but we're going to use some of it in questions and always use the formula that they give you. But before we go to break, and I think I've got time, hey Kat?
Yes, I think you have a few more
Have I got enough time?
minutes, yeah.
Converting from one unit measure to another when it's squared and cubed. Now, my trick to you, and honestly, if you can follow this, then you never have to worry about how to convert it. Have a look and see what do they want the answer in. So if they want the answer in meters squared or meters cubed, convert everything to meters first. If they want the answer in centimeters squared, convert to centimeters squared. So by this way, we avoid converting once we've got it into a squared unit or a cubed unit. So always try to look at what the answer. But if you don't, and we have a problem, and what I want to do is I want to actually show, before I go back to the notes, I want to show you a square. So if I look at a square, and I look at 1 meter squared. Now, 1 meter squared means that each side is 1 meter long. Okay, so length times breadth, and I get 1 meter squared. But how many centimeters are in a meter? So we've got 100 centimeters in a meter, and 100 centimeters in this meter. So what is my area here? It is actually 100 times 100. So we end up with 10,000 centimeters squared. So I know your instinct is to say, no, there's 100 centimeters, so all I need to do is times by 100. What I'm telling you is you need to times by 100 squared. And I've written it out, and you can pick it up in the notes if you download the notes, which I hope that you do. So what I've done is I've given you one dimension, which is what we did last week. So 10 millimeters is 1 centimeter. And then if we look at the 2 dimensions, 10 millimeters is now 10 squared is 1 centimeter squared. So we have to square the unit. So we're still going to our base 10 or 100 or 1,000, but I want you to square it. And the same thing with now cubed, where we've got 3-dimensioned is cubed, so it's 10 cubed. So just be careful of that, because this is a mistake we pick up over and over and over again. So either convert first, you don't have to worry about this, but if you don't, let's just do a quick example. Let me find an example here. Let's do a quick example. If I want to work out 3 meters cubed, and I want to work it out as how many centimeters cubed is that. So how do we do this? Let's change our color. So we'll use this blue. Okay, we find our centimeters cubed on the one side, meters cubed on the other. So I'm looking at that line here. I'm going from a small number to a big number, so I'm going to multiply. And what am I going to multiply? I'm going to multiply by 100 cubed. Now, if the units get in your way, then let's delete the units, because they might. Let's delete those. And I'm going to get my calculator out, and I'm going to say, well, on my calculator, I'm just going to say 3 times by 100 cubed, and I get my answer. And you can quite clearly see that it is 3 million. So much bigger than we expected. Let me get a pen. It's 3 million centimeters cubed. Okay, I hope that helps. But convert first, then you don't have to do it. But I think maybe we should give them a little break.
I think it's time for a little break, Haley. I think
so.
they deserve it. So guys, we're going to go for a very, very short break. During this break, I want to remind you guys to download some notes. We have an awesome, awesome webpage, and you guys need to jump on it. And that is www.learnextra.co.za/live. So download those notes, guys, and we'll see you right after this break.
Welcome back, Mindsetters. I'm still with Katla and Haley doing beautiful mathematics here. I believe everyone needs this show. You can still get our notes on www.learnextra.co.za/live, and life will be simple like that.
Over to you, Haley.
Thanks a lot, guys. Okay, let's start with the questions, because the best way to do this is actually to do some examples. So, first question comes out of your Solutions for All Maths Lit, grade 11, topic 8, page 227, question 2. Sounds like such a mouthful. Yulissa wants to paint the front of her house. She has 2 windows as well as a circular vent near the roof. So we're going to look at the pictures of her house. So we're looking at what they call the gable. That's the top of the house. Okay? She's got the circular vent and 2 windows. So there's her house, a lot clearer. And I don't think you can actually see the writing here, but that's the vent. Let's make it vent. That's the vent, and this is the gable. Just to make it a little bit clearer. Right. The 2 windows are identical. Calculate the area of 1 window. So, quite easy. We're looking for the area of a window. I always like to write out my formula. So the area, we're looking at a window. It's a rectangle, length times breadth. Now we can substitute, and in actual fact, I'm going to go in here and I'm going to write in my length and my breadth, because it makes it easier for me to remember. So my length, I said, was 0.6 meters, and my breadth was 1.2 meters. And again, doesn't matter which way you put them. And sometimes the meters, the actual units, worry people. And sometimes we don't know, and especially when we've got like meters squared, and then we think must we square the number. So you can actually totally leave those out. And you could have written it as 0.6 times 1.2. Most important thing is, do you have your units in the answer? So 0.6 times 1.2, and we get an answer of 0.72. So our answer to that is 0.72, and this is now meters squared. Now don't forget your units, and it's an area, so it's squared. Let's see what the next question is. Calculate the area of the vent. So now my vent was a circle. My vent is a circle, and what I have on the vent is I have 0.5 meters as my diameter. So whenever I have a circle, remember from last week, all I do first is work out the radius. So my radius of my thing is now my diameter divided by 2. So that was 0.5 divided by 2. And my calculator, I need it, 0.5 divided by 2 is 0.25 meters. And now I want the area of this. So the area of a circle is pi r squared. So we're going to take our pi, and I'm going to use the number 3.14. We can use pi on the calculator, and 0.25 squared. And this is where sometimes meter squared and squaring gets in the way. So I leave out the units. On the calculator, we've got 3.14 times 0.25 squared, and we get 0.19625. 19625. I'm not rounding off right now. I could round it to 2 decimal places. I'm not going to round yet because I know at the end they ask me for like the total area to be painted. And I'm thinking that's where they're going. So let's leave that as it is. Let's move on to the next part of the question. Calculate the area of the rectangular part of the wall. So my rectangle, there's my length, there's my breadth. So area is length times breadth. And that was 5 meters times by 2,6 meters. Work that out. And that's 13 meters squared. So don't forget your units. Really, really important that you have your units. And finally, they ask us to calculate the area of the gable. Now that is my triangular part. Okay, so my area here is the area is half the base times the height. That's the perpendicular height. So firstly, I'm going to delete this just to remind you of what this length is of the base of the gable. And that is the same as the length of the bottom of the house, my rectangle. I'm going to show you that with a line. If I draw a line from there to there, that's my 5 meters. Okay? And if I click on it and move it up, I see that that is 5 meters. So remember that your opposite lines, especially when you've got triangles and when you've got rectangles and squares, they are equal. So this is then half. I need a pen. Let's go back to a pen. So it is half times my base, which was 5, and the height, my perpendicular height is now this one going down here. That's 1.8 meters. And on my calculator, now, this is something that totally perturbs me. And Topo, I don't know if you did it. I'm going to put you on the spot. Oh. When you work out area of a triangle, and you get something like half times 5 times 1.8, is your instinct to say half of 5 is 2.5, and then say 2.5 times 1.8? Is that your instinct?
Yes, it would be.
It would be instinct. Now, this is what biometrics are doing as well. And I say to them, but why? We've got a calculator that can do this for us in one step. Why do we have to worry about this half? So, because they tend to do that first as well. But you've got a calculator. So what is half on a calculator? I can write it in as 0.5 times 5 times 1.8. So I don't have to work that out in my head, because my calculator can do it for me. And I always like to trust the calculator. So I think you guys must get used to this as well. Practice on your calculator and trust your calculator. It can do it. And we get an answer of 4.5. What color were we in? 4.5 meters squared. Okay. Then the final part of the question is actually putting this all together. So the question then says, show that the area to be painted is 15,86 meters squared, and set out your work clearly. Now, I don't think I'm going to set out everything. Well, I'm not going to do all the calculations. I don't want to go back and get those numbers. But what are we looking at? We're looking at the area to be painted is the area of the rectangle plus the area of the gable. So we're going to add those up. So that's the entire wall. Then we're going to minus the windows. And how many windows have we got? We've got 2 windows. And then we're going to minus the vent. And what's really nice about a question like this is that they're basically giving you the answer. So when you set it out, make sure that your teacher can follow your train of thought exactly. So I'd say, well, area of the rectangle was that, area, and set it out like that, and that's perfect. So I'm sure if we did, we would get that answer. Let's move on, though, to the next question. So also from the same textbook, the grade 11, now we're dealing with topic 6 and page 171, and it is question 1. So in this particular question, we've got a new interactive electronic whiteboard is being fitted into a classroom. So then they give us diagrams. I always like to read and interpret the diagrams before I carry on with the question. So what's my diagram? I've got the classroom wall. I can see that it's 7.2 meters long. It's 2.6 meters high. And I've got my interactive whiteboard, which is 1.3 meters long, 900 centimeters high, and that's my board. Now, straight away, as soon as I've looked at this, there's alarm bells going off in my head. Why? Because I'm dealing with meters and centimeters, and I'm seeing that as a problem. So the first thing I want to do is I want to actually convert this, and I'm thinking that there's a mistake in this as well, and it should have been 900 millimeters. So I'm going to change this. Let's get a white paper out, and we're going to change that to millimeters, because 900 centimeters does not make sense in this context. So we're first going to convert that. So let's get a color pen again. We're going to convert that to meters. So how do we do that? Do we remember? I'm going to write these 10 to 1, 100 to 1, and 1,000. I don't think I need the 1,000, so I don't even need to write it. Right. I've got, what was that in yellow? This was millimeters to centimeter, centimeter to meter. So I need to go through both steps. I'll take a different color to show you. We're going from there to there. I am going to, from a big number to small, so I'm going to divide it. So I'm taking my 900 millimeters. I'm going to divide by one with 1 0 and another 2 zeros by 1,000. And then I'm going to get 0.9. Let's do it on a calculator. 900 divided by 1,000. And 0.9, I always like to double check. So that was 0.9 meters. And I'm going to go back to my diagram and actually write that in there, 0.9 meters. So now that I've got that, it makes it easier for me to complete the question. So the wall is 7.2 meters wide. The interactive whiteboard is 1.3 meters wide. Now we've seen that. If the interactive electronic whiteboard should be in the middle of the wall, how much space should be on either side of the interactive electronic board? So we're looking at, right, let's redraw this. I have my board, my wall is 7.2 meters. I want to put this in the middle, and that's 1.3 meters. And I want to know how much space is on either side of that. So the question is, how am I going to do this? Well, first of all, if I take my 7.2 meters, and I minus my 1.3 meters of the board, that's going to be how much space is left on the wall. So let's do that on our calculator. I got 7.2 minus 1.3, and we're going to have 5.9. So we actually have 5.9 meters of space. I want it in the middle. So I'm going to divide it by 2 because I want an equal amount on either side. So let's divide that by 2, and we get an answer of, got that on our calculator, divide by 2, and we're 2.95 meters. And this is one question where we are not, or don't forget your units, we are not going to round off at all. First of all, it's 2 decimal places, and we always say work in 2 decimal places. But the other thing is they wanted to know exactly how much was on either side. So don't round off this question. Don't forget your units. Go back and recheck the question. It said how much space should be on either side of the interactive electronic whiteboard. I've answered that question. It was 2.95. Right, let's see what the next part of the question is. The top of the interactive electronic whiteboard should be 1.8 meters above the ground. How high will the bottom of the interactive electronic whiteboard be from the ground? So again, I'm going to draw this So I have my classroom. Now I'm dealing with this 2.6 meters. I just want to double check that that was 2.6 meters. Right, and I need the top of the board must be 1.8 above the ground. So that's the top of the board, and that needs to be 1.8 meters. And we want to know how high is the bottom from the ground. So I have my board starting there, 1.8 meters, and my board was 0.9 meters wide. So in this case, all I need to do, because once I've drawn it, it makes it clearer what I actually need to do. So in this case, I need to take, let's change our color. I need to take this 1.8 meters and minus the board. And we get, so it was 0.9 meters from the ground. And I'm going to try to finish this question. I know we need a little break, but let's do the last part. What is the distance between the top of the board and the ceiling? Well, now quite clearly, if I go back to that drawing, well, let me quickly redraw it. I had the top of the board at 1.8 meters, but my whole wall was 2.6 meters. So what do I need to do? I need to take 2.6 meters and minus the 1.8 meters. And for that, use a calculator. And we see that it is 0.8 meters from the top. Have we answered the question? Distance between the top of the board and the ceiling, we've answered the question. In this case, we would be able to see everything. It would be perfect. And I think it's time for me to hand you over to Kat and Seppo for...
Thank you, Hayley.
See
So,
you now.
guys, we're going to take a break. Do you want to break? Most of our mindsetters never want to break, Topo.
Guys, let's grab a glass of water, refresh up, and
We'll see you right after the break.
yes.
Welcome back, Mindsetters. So, we've been doing some maths literacy, guys. It's been really, really awesome. And Topo and I have learned a lot. Haven't you learned a lot?
I've learned a lot.
I
I've got
know.
the key concept.
The volumes and the
volumes,
surface
you know.
areas. And this is all on our notes, guys.
Yes.
So don't forget, please, please, please download them, print them, share them, stick them up on your
Yes.
walls, anything, because it makes life so much easier.
Easy, yes.
Highlight them, anything, right? You used to highlight
Yes,
everything.
I
eh?
used to do it on your walls. Just
Even-
when you wake up, you see it first, then you'll remember it. So,
Exactly,
yeah.
exactly. Over to you, Hayley.
Thanks, Kat. And don't forget to tell them that they can actually get the videos.
Yes,
On that same-
yes, on the same site. You
But
get the
maybe it's a-
schedule, you get the notes, and you get the videos. Obviously,
Yes.
not right now because we're talking right now, but after the show, you are able to watch those videos, guys. It's really, really important. In case you want to recap.
Absolutely. Or you didn't understand something, you can go back and see, well, what exactly did I do and why did I do it? Although I'm hoping that you do understand everything.
I
So-
think they understand. Their
Uh,
mindset is off.
Absolutely, absolutely. Well, in the right place. Okay, let's carry on. So question 3 now, we've got also from the grade 11 textbook, and topic 8 now, page 227, and question 3. So we've got a tin of coffee, and it has the following dimensions. The radius is 5,1 centimeters. We can see that there. And the height is 16,2 centimeters, and we can see it in our picture. So we've got our coffee tin, we've got our 2 dimensions. It says calculate the capacity of the coffee tin. And the reason I added this question was that it's important to know that capacity means the volume. So we are looking for the volume in this case. It is a cylinder, so my formula, and they will give you the formula. So the formula is your pi r squared h, and I'm going to use pi equals to 3,14. I did that earlier, and I didn't quite explain why. Most of your exam questions come out with use pi as 3,14, and especially for you grade 10 and grade 11ers, you do not have to have a scientific calculator. So you don't have this power button on your calculator. Well, you don't have to. So this little power button that I've got on the calculator, which if I press equals will tell me it's 3,14159, we don't have to use it. So we do have to use the simplification of that. So we use pi equals 3,14. So go back to my calculation. Now, once I've got my formula, it's easy for me to actually substitute in the number. I know what pi is. I know what my radius was. I must just find it. It was 5,1. 5,1 squared. And if you don't have a scientific calculator, then it's 5,1 times 5,1. And times that by my height, which was 16,2. And my answer is going to be in centimeters. So let's get my calculator out. So it was 3,14 times 5,1 squared times by 16.2. and I get an answer of 1323,076. Now I want to talk about this rounding of this number. So 13, let's write it out exactly. 1323, now I can't remember it. 1323,07668. 07668. Okay, so I want to talk about the rounding of this. This would be centimeters cubed. When we round in this case, we've got to be very careful. My instinct is to round up, because whenever I want to go to 2 decimal places, and that, if I underline, let's do a different color. If I underline my second decimal, look at the number after it, I need to really, in theory, round to 0.8. Problem is that that's not going to fit into my coffee tin. I've got a very finite space. So whenever I'm working out the capacity of something, the volume of something, I actually need to round down. So in this case, I'm actually going to make it 1323 centimeters cubed. If you want to make it 0.07, that would also be fine. So be careful with things like that. And it's always better if you don't know. Write out the number, then maybe you could even do the rounding and then like another rounding to show that you've rounded down, just so that your teacher can follow your train of thought. Okay, let's move on to the next part of the question. The next part of the question says, now the tin is 3/4 full. How much coffee is in the tin? So now I have my volume of the tin, which was my 1323 centimeters cubed. But I only have 3/4 of the tin full. So we're going to take that answer times by 3/4. You can use a fraction. You can use 0.75. You can times by 3, divide by 4. Okay, and we get an answer of 992.25. 992.25. And don't forget, that was centimeters cubed. Okay, let's move on now to some metric questions. Right, this particular question was adapted from the DBE Feb-March 2012 paper. It's a paper 2, question 5. The sandwiches are made from 2 square slices of bread with a filling in between them. Each side of the sandwich is 110 millimeters long, and it is 30 millimeters thick. And then they've actually shown us a diagram of the sandwich. So we can see that we've got 110 millimeters long, and it's a square piece of bread, and 30 millimeters is your thickness. Each square sandwich is cut diagonally to form 2 triangular pieces, which are stacked next to each other. So that's important. They are then packed into a box shaped like a triangular prism, as shown below. So we can see that our sandwich, and this looks like a delicious sandwich, making me kind of hungry. What about you guys?
I think that's a great sandwich.
So, right, we've got our height and our base is 110 millimeters, and the thickness is now 60 because we've got these 2 sandwiches stacked next to each other. And then finally it shows us what the diagram looks like with the packaging. The dimensions of the box are 5% greater than the dimensions of the sandwich. A rectangular sticker of the Tasty Sandwich Company logo is pasted onto that diagonal side of the sandwich box. So you can see where that sticker is. Let's see what the question says. Determine the diagonal length, rounded off to the nearest centimeter of the sandwich. So we're going to work out the diagonal length of the sandwich. And it gives you a formula to use, which is the diameter, because D is the length of the diagonal, and S is the side, is the square root to the square rooted times the side. So we're going to use this formula, and then I'm actually going to show you how they derived the formula. So my diagonal is what I'm looking for. I want root 2 times the side, which was 110 centimeters. So it's as simple as that. I'm using the formula they're giving me, and that is the root 2 times, and just make sure that you when you press your times, it's not carrying on under your root sign. But before I do that, just occurred to me that they wanted the answer in centimeters. And what was 110? 110 was in millimeters. So we need to convert this first. So 110 millimeters, and we divide by 10, gives us 11 centimeters. So rather than doing that, I'm going to erase that, and I'm going to times by, let's go back to my green pen, times by 11. So on my calculator, times by 11, and I get the answer of 15,56. 15,56 centimeters. Now, what I want to do is I just want to go through where that formula came from, because one thing that I haven't done in our volume and area is Pythagoras. So let's try to get a nice triangle. See if I can get a nice triangle. No, that's not going to actually work. Never mind. Okay, let's get a triangle. Right. Our Pythag is when we've got a right angle triangle. And we always say that my side squared are equal to the hypotenuse squared. So in this case, it's x squared plus y squared equals r squared. Now, in our sandwich, we had those sides. So we actually had this was 11 centimeters, and that was 11 centimeters. And we were looking for the radius. So what we had was, we actually had 11 squared plus 11 squared, but I want to do it with numbers rather than the 11. I want to do the side. That's where, yeah, let's do this. It was side squared plus side squared equals to r squared. And if I've got two sides that are the same, I can make that 2 sides squared equals to r squared, and now I square root it. And that's where our formula came in, was that we had the square root of 2 times the side. So either way, we would get the answer. So I hope that you can follow that kind of logic, but Pythagoras, remember, they're going to give you the formula. So use the formula as it is, and we got our answer. So it was 15,56 centimeters. Then the next part of the question said, right, the ratio of the length of the sticker to the length of the diagonal side of the box is 2 to 3. Calculate the length of the sticker. Now, the first thing we need to do is we need to work out the diagonal side of the box. Because the diagonal side of the box, our sandwich was 15,56. Our sandwich was 15,56 centimeters. Oops, left out my centimeters. And we read somewhere that the box was 5% more than that. So we need to increase this by 5%. So I'm going to times it by 105%. So 15,56 times by 105% to get my answer of 16,34. Let's round 16,34. So that is now the diagonal side of the box. Now it tells me that my sticker to my box was 2 to 3. And I'm looking at the length of the diagonal side of the box and the sticker. So that's my sticker, that's my box. So then I'm going to fill in my numbers. That is 16,34. And this is what we're looking for, my question mark there. And now it's clearly just a ratio. So when we do a ratio, remember, we work out what do we do from 3 to get 16,34. We times by the second number over the first, and we do the same thing on the other side. So I'm going to rewrite that. So I've got 2 times by 16,34 over 3. And let's do that on the calculator. 2 times 16,34 divided by 3. And I get an answer of 10,89. Now, I'm expecting an answer that is smaller than the box. I'm expecting an answer that's smaller than the box. So because I've got an answer that's smaller than a box, I think to myself, well, I've probably got that right. So these are the kind of checks that you guys should be used to doing regularly. Make sense of the answer. Does it make sense? So if I would have got an answer of like 20 centimeters, I thought, well, hold on a second. It does not even fit onto the box. So be careful of those kind of things and make sense of the answer. Let's see what our next part of our question is. Right. The boxed sandwiches need to be packed into a rectangular carton that is 94.6 centimeters long. I don't know if you can see that there. 58 centimeters wide, that's that number there, and 36 centimeters high. So we're going to be packing the sandwiches. The sandwiches will be packed upright as indicated in the sketch below. So what we're doing is we're taking the sandwich and we're packing. I'm going to try to redraw this. Maybe if we redraw it, it'll be a bit better. Right. We are packing the sandwiches, one sandwich there, and then one kind of upside down. So we've got two sandwiches sitting in that space. Determine the maximum number of boxed sandwiches that can be packed into one carton and clearly show all your workings. So what I'm going to do is I'm going to redraw my sandwich. So I have a sandwich, right, that is actually three-dimensional. Right. This side of the sandwich was 11 centimeters, and that side was 11 centimeters. Now I'm going to be putting a second one, but my height here was 60 millimeters or 6 centimeters. I've just converted it for you. I need to now work out the box, and each one of these needs to be 5% more. So I'm going to take my 11 and times by 105%. Okay. So 11 times 105%, and I get 11.55 centimeters. So that's my length. And my breadth is the same, and then finally my 6 centimeters times by 105%. Let's see what that is. 6 times by 105%, and I get 6.3 centimeters. Now I take my box, and in the bottom of the box, which was 94.6 centimeters long. So I'm going to change colors. So 94, let's do it this way. Right, this was 94.6 centimeters, which is nearly a meter. How many of these 11s can I fit in? Well, the 11.55. So I'm going to divide this into however many 11.55 I've got. So I'm going to take my 94.6 and divide by 11.55. So I've got my 94.6 divided by 11.55 and see how many boxes. Now I've got 8,19 boxes. Can't put a comma 19, so I'm going to go with 8 boxes. So I can fit 8 boxes in this way. And now I'm going to redraw. So I'm going to actually use a different color and say, no, different color. That wasn't a different color. Okay. I can fit 8 boxes in that way. And then I'm going to do the same thing for the height of the 58 centimeters and the same thing for the breadth. And what I'm going to end up with is I'm going to end up with 3 values, and then I can multiply those out and get how many sandwiches I need in the box. Does that make sense? But I think on that note, guys, I'm sure that coming to the end of our show, and I'm going to have to hand you over, but just remember, practice, practice, practice.
Exactly.
Practice.
Yes.
That always helps, eh?
It does.
A lot of revision, a lot of practice. That's all it takes to be a fantastic mindsetter. So, Topo, how was that?
That was a brilliant show, guys. I hope you're able to apply your basics of calculating things now.
Yeah, no, I know that they can. They are mindsetters after all, hey. And I'm sure many people at home are also watching you thinking, that's my boy,
Yes,
Topo.
yes. Hi to my family. Hi to my friends on TV. Huh?
I know Topo is excited to be on TV. So guys, that reaches the end of our show. I hope that you guys really enjoyed that. Thank you to Macmillan for sponsoring such an awesome show for you mindsetters. So see you next time, same place. Bye guys.
For the triangle. So that's the triangle, and we've got 2 of those. So that's easy enough to do. And then we've got side 1 times height. So if I should take my triangle here and make this side 1, let's change that a sec. Let's undo that for a sec, make it easier. This side 1, that side 2, and that side 3. My rectangle is the side 1. It's the same side as that side of the triangle times the height, and this becomes the height of the shape. Side 2 and side 3. So we end up with 3 rectangles. And this really does depend on what your triangle measurements are. So pick it up from there. And again, probably easier to label them. So label side 1, side 2, and side 3. And then you know that that's your height. So it makes it easier to substitute into the equation. Then let's move on to our cylinder. And again, this is a shape with 2 equal circles and a rectangular face. So let's change color for a bit. We've got a circle. There's my cylinder. Whoops. If I had to actually unfold it, I have got 2 circles, a rectangle. Well, that's 1 circle. Let's put the other one in. And that circle. Now, what's important to note about the cylinder is that this shape over here. Welcome.
What
Good
are
to
we
have
doing
you here.
today?
Today we're going to be doing measurement.
Okay.
And we're going to be looking at, last week we did measurement, we did area and perimeter. Today we're going to be doing volume and surface area. So it's going to be fun. So
Thank you guys. So it's going to be a lot of fun. And today our show is sponsored by Macmillan. Thank you very much, Macmillan, for sponsoring such an awesome show. Take it away.
Thanks. Okay, so like I said, we're doing measurements. So we're going to look at measurements, carry on from last week. So let's just look at what we're going to be doing. We're going to focus on calculating the surface area of rectangular prisms, triangular prisms, and cylinders. We're then going to focus on calculating the volume of the same prisms, the rectangular, the triangular, and the cylinder. And finally, something that I know a lot of you guys actually struggle with. And I'm going to explain when I do the calculations how you avoid this, but converting from one squared or cubed unit of measurement to another. So when we end up with an answer of like centimeters squared, and they want to know the millimeters squared, what do we do? Because I know that most of you guys actually struggle with that. So let's see what our key concepts are. So our key concepts for today. So in order to calculate the surface area of a 3-dimensional shape, what we basically need to do is flatten the shape and calculate the area of all the sides. So kind of like if you take your 3-dimensional shape, but then it makes it easier to substitute the values into the equation. And you don't end up thinking, well, have I done this one already? Or have I left it out? Or what is the situation? So it's quite easy. So we're looking at 2 of those, because there's 1 there and 1 at the back, 2 of those, 1 at the top, back, and 2 of the sides. So follow the formula. Let's move on to the triangular prism. Now I'm going to try and draw one of these. So triangular prism is also a 3-dimensional shape, 2 equal triangles and 3 rectangular faces. So if I had to draw it, I've got a triangle, and that would be like kind of 3 dimensions. Right, so what do I have here? I have this triangle here, and at the back I've got the same triangle. Those are my 2 equal triangles. And then each side, so if I actually had to unfold it, I've got a triangle that's attached to the base, and on the opposite side of that, a triangle. And then I've got a rectangle and a rectangle. So So that is why if we unfold it, we can see we've got 3 rectangular faces. There's 1, 2, 3, and we've got 2 equal triangles. So the formula is the 2 times half base times height. That is the formula. This formula in the brackets is shape, and you unfold it so that it's flat. And then you've got a 2-dimensional shape, and you just work out the area. So there's nothing really hard about it. It's just a little bit of understanding. We did area last week, so I'm hoping that you guys just follow on. A rectangular prism is a 3-dimensional shape with 6 rectangular faces. The opposite faces of a rectangular prism are always equal and parallel. So it's important to know that. If I look at something that was a rectangular prism, I've got those 2 sides are equal, those 2 sides are equal, and then the top and the bottom are equal. Then they will always give you the formula. So don't panic. And please, I had an incident with my matrics today where they decided to make up their own formula. Use the formula that you are given. So for surface area, it's basically 2 times the length times breadth plus 2 times the length times height plus 2 times the breadth times height. Sometimes they take this 2 out and they say, well, it's 2 times length times breadth plus length times height plus breadth times height. What I want you to do, I'm just going to quickly draw a rectangular prism. What I really want you to do when you see this in your test or in your exercise, take a pen and label each one of the sides. So make that the length, make that the breadth, and make that the height. And it really doesn't matter which is which.
Hello guys, welcome to Learn Extra Live Maths Literacy. I'm Katleho and this is Topo. How are you, Topo?
Hi, I'm fine, thank you. And you?
Good, thank you. Topo is one of our top 10 presenters, guys. How does it feel?
It's nerve-wracking at the same time. I'm enjoying, hey.
That's
it's a nice
great, eh?
opportunity
And
to
how
be
does
here.
it feel to be here today?
It's overwhelming. I met everyone and it was nice, you know.
It was nice, eh?
Yes,
We
yes,
also
yes.
enjoyed it here. And guys, you guys know, those of you who have been in the studio, it's really so much fun. And guys, since we're doing maths literacy today, it's Thursday, it's a stunning day. You guys need to focus, guys. All we need today is your 100% attention because it's going to be such a fantastic show. We are on Facebook, as you guys know. This is where you can ask anything that you need to ask. Our Twitter handle is @LearnExtra. And do you remember our Facebook?
Yes, you can go to www.facebook.com/LearnExtra and you can post any question that you have.
That's it, Topo. Guys, you heard him. We are here to help you guys. There's 2 of us, so it's double, I don't want to say double trouble. What's another word that we can use?
Double joy.
Double joy, yes. It's double joy. And today, we're with Haley. Haley, how are you today?
Okay,